Hi, welcome to this tutorial session where we are going to learn on how we can apply the concept of machine learning in developing predictive model using Python. To start with, let's see the definition of these two items, the machine learning and the supervised machine learning. So, machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve the experience without being explicitly programmed. And the supervised machine learning is where you have the input variable X and the output variable Y, and you use an algorithm to learn the mapping function from the input to the output, such that Y is a function of random variables X. So the goal is to approximate the mapping function so well that when you have new input data, that you can predict the output variables for the data. So after having these two concepts on machine learning and supervised machine learning, then let's go to the Python and see how we can apply this concept of supervised machine learning in developing a predictive model using Python. Okay, this is the set of our data set that we are going to apply, and I have the data set for the sources of road accident with the respective total fatalities from different years. So let's go to Python, and here already have loaded my data, and you can see my data. I have saved them in a CSV format. So I have to read my file as CSV. So the name of my data, you can see here, is the accident data. And then now I added this encoding as a Unicode escape, because if you run my data set, if you command the print, it gives me an error showing that there is a special character or a space somewhere inside my data set. So this one basically clear, and I can show you. Let's cut this and see what will happen if you run this without that code. So you find the error code which I get is UTF-8. Basically, it indicates that there is a special character or a space in labeling my variables or inside the dataset. So I have to add this one to clear that doubt, and when you run it, it will give you the output. So these are my variables, and now let's split the dataset into dependent and independent variables. So my independent variables, I'll just pick two independent variables, which is the vehicle defects and the speed. Okay, so the dependent variables, this, as usual, you write two square brackets because we are taking or we are developing a subset from a main data frame DF. So my two independent variables, so these are the two independent variables which I'll be using in developing a predictive model. And the predictive model is basically concerned with how we can predict the total fatalities when we have the number of cases in vehicle defects, okay, or sources of accident, okay, based on the vehicle defects and the speed. So the Y variable is the dependent variable, will be the total fatalities, and this is T fatal. Okay, so after having this one, now in machine learning, we are not going to use all the data set that we have in developing a predictive model. So we have to split the data into training set and the test set. To do that, we have to call the function train test split, and that is from scientific kit. So from import train test split. Okay, so we are going to split the data set into train set and the test set. So that means for the X variable and Y variable, we are going to have two sets. one for the training set and the other is for test set. So we are going to have X train set and X test set, also Y train set and Y test set. Okay, so this will be obtained from splitting the the data set in variable X and Y. So we call the train split function, and we are going to split the X, and also we have to decide the test size, how many data we will reserve for testing our model. Okay, the training set basically is the set which will be used in developing or a predictive model. So we are going to reserve 20% of our data set for testing. So the test size, let's take the test size, it will be 20%, that is 0.2. And we have another command which is the random state. This random state basically, let's put 10. Okay, the random state basically what it do is that when you are running your model several times, so the number of samples will not be changing. That's which have been split for the training and test. So after splitting, you can now print to see your sets, especially just print for the X train and Y train, which we are going to use them in a developing predictive model. Okay, and also Y train set. So run this one. See, you can see now we have this the head part, this one, and this next two columns represent 80% of the data set from our main data set, which will be used in developing our model. These two variables are the X set, and the Y variable, the total fatalities, the 80% of our data set, this one respectively. So you can see this sample data, the 8% for X and Y, they are corresponding. You can check the ID. This is in the 11th row. The same, the first one is in the 11th row, 23rd, 13th, and you can see. So they are matching the Y and the for the X. So now we are in the position of developing our predictive model. But before that, let's add a constant into our training set of X, because this is the right hand side of our regression model. So if you use this one in developing a regression model, then your regression model will miss the constant or the beta node. So let's add that, and before that we import the start model .api as SM. Okay, and after that, now let's add a constant to our right hand side of our regression model, because we are going to use a linear or multiple linear regression model to develop a predictive model of total fatalities based on these sources of traffic accident. So let's add the constant to X train set. So we create a new X train sm.add constant, and we add constant to the previous X train set. And also we have to add a constant to X test, because later we are going to test our model prediction power using this set. So SM, so we add the X test. So we are done adding the constant to the right hand side of our independent variable so that it makes a complete right hand side of our regression model with the beta naught. So now we estimate the coefficient of the parameter in our model using the ordinary least square method. That is sm.ols, and this inside this ols we have the y train as a dependent variable, comma, don't exchange this, you start with the dependent then independent variable. So we have y train, comma, x train. Okay, then as in other linear model we have to wind up with the function fit. So here we are done fitting our model into ORS, and now we can print this summary, print the regression summary, linear model.summary. Okay, if you print this one, now let's see the output summary for a regression model. So you can see the output here. Let's enlarge this one. So we have the output for the ordinary least square regression results with the adjusted R square for the dependent variable total fatalities being 72.3%, and we have the p-values here, and we have this confidence interval, and our variables are here and the constant there. So there is a significance contribution of these vehicle defects and the speed on the total fatalities, but at only 72.3%. So this is how you can now develop a regression model using the train test split method. Remember, we developed the model using the train set of X. Now we need to test the model if it works efficiently. Okay, so to test the model if it works efficiently, remember also we have the reserved values for Y, okay, which corresponding to the reserved value of X, which is the test set for Y and the X. So now we are going to use the X test set to see if the model can predict exactly or approximately as the Y test value. So to test our model, now we have Y predict, okay, from our regression model LMM, which is the regression model we developed, which is this one. So LM predict function, and then inside the predict function we are going to use the set of X tests, okay, to predict the values of Y. So now let's print Y predict and also Y test. Remember, the Y test are the reserved value or values of Y, which will be compared now with the predicted value. So run and see the results. So you can see we have 20,000 plus, okay, these are predicted values by our developed model, and these are the reserved values of Y, okay, from the main data set. So is these values, predicted values, comparable to the reserved values of Y, and on what percent? Remember, our model, we have seen its predictive value is 72% accuracy. Okay, now you can check the prediction here is 20,000 plus, this is 23,000 plus. Okay, this is 12,000 plus the test set, the predicted set is 13,000, okay, plus. So there is a minor difference, and this is due to some of the percentage left from our prediction model, okay. So this is how you can develop a predictive model using the concept of supervised machine learning. So thank you for watching. Don't forget to subscribe, comment, like, share the link of this channel. Thank you, and don't forget also to click on the bell to be notified once we upload our new video.